Let's see one very important question which was asked in UGC CSIR NET 2011's question paper in part B. Statement of the question is for constant uniform electric and magnetic fields, that is vector E is equal to E0 and vector B is equal to B0, it is possible to choose a gauge such that the scalar potential phi and vector potential A, vector A are given by, there are four options given. You have to find correct answer from these options. Let us see how one can solve this question. Since vector potential is defined by this equation, that is vector B is equal to del into A, and if we consider A is equal to 1/2 in bracket B0 into R, we have to consider another vector identity from vector algebra, that is del cross A cross B is equal to B dot del into A minus in bracket A into del into B plus A vector A in bracket del into B minus vector B into del dot A. By considering this vector identity, we can have this equation, that is del cross is equal to 1/2 in bracket minus vector B0 into del bracket close into R plus in bracket R into del bracket close into B plus vector B in bracket del dot R bracket close minus R into in bracket vector del into B bracket close. Let us see four different terms, how to calculate the answer of four different terms for this equation. For first term, that is vector B0 into del into R, here I have calculated. So in bracket B0 del into R is equal to, putting the value of Laplacian operation del, so we can have in bracket del Bx over del X plus del By over del Y plus del Bz over del Z into I caret X plus J caret Y plus K caret Z. So we can have constant uniform magnetic field vector B0. For second term, that is in bracket R into del bracket close into B, we can calculate this term like this way, is equal to in bracket del X over del X plus del Y over del Y plus del Z over del Z into B0. So we can have value 0 for second term. For third term, that is vector B into del into R, we can have this equation. Del into R is equal to I caret del over del X, J caret del over del Y, K caret del over del Z into I caret X, J caret Y, K caret Z. So we can have 3 for third term. For fourth term, as divergence of magnetic field is 0, fourth term will be del into B0 is equal to 0. Let us consider electrostatics. Here phi is equal to minus vector E0 into R. If we consider divergence here or gradient, equation of gradient, that is del into phi is equal to minus del into in bracket E0 into R by putting the value of phi from here. So we can have this equation, that is vector del into phi is equal to minus del in bracket I caret Ex plus J caret Ey plus K caret Ez into I caret X plus J caret Y plus K caret Z. It means the value of this equation, that is vector del into phi is equal to minus E0. So by this way we can find the correct answer, and the correct answer is phi is equal to vector E0 into R and vector potential A is equal to 1/2 in bracket vector B0 cross R vector. So correct answer will be option B.